In this video, I will present the SISAL and the SODA-AQ curricularity. So first, let's know what is SISAL. SISAL plants consist of a rosette of sword-shaped leaves about 1.5 to 2 meters, 4 feet 11 inches to 6 feet, 7 inches tall. Young leaves may have a few minute teeth along their margins, but lose them as they mature. The SISAL plant has a 7 to 10 year lifespan and typically produces 200 to 250 commercially usable leaves. Each leaf contains around 1,000 fibers. The fibers account for only about 4% of the plant by weight. SISAL is considered a plant of the tropics and subtropics, since production benefits from temperatures above 25 degrees Celsius, 77 degrees Fahrenheit, and sunshine. Then that's the reason why I choose SISAL as the raw material, have the rich content of polycellulose and poor content of lignin. Also, SISAL pulp has physical properties superior to softwood pulp. There may be opportunities to cost-effectively replace softwood pulp with SISAL pulp in commodity papers. In the chart we can see, SISAL is indeed suitable as pulping raw material. The reason why I choose SODA-AQ pulping because first, higher pulp yield. SODA-AQ pulping increases pulp yield due to higher lignin removal efficiency and lower carbohydrate degradation. Second, lower kappa number. When anthraquinone, AQ, is added, delignification is accelerated, which reduced the kappa number considerably. We can see the difference about soda pulping NS60 and SODA-AQ pulping NS60AQ-15 from the table. Black liquor is concentrated in multiple effect evaporators to approximately 50 to 65% solids and fired in a soda recovery boiler, organics, mainly lignin, combust to generate high-pressure steam, the mill's process energy. The inorganic salts melt into a smelt bed. Because SODA-AQ liquor has no sulfide, the smelt is nearly pure sodium carbonate, Na2CO3, rather than the Na2S, Na2CO3 mix in craft. The molten smelt is withdrawn and dissolved in weak wash to form green liquor, primarily sodium carbonate with minor sodium sulfide. This green liquor is sent to the causticizing cycle. It is mixed with slaked lime, calcium hydroxide, so that sodium carbonate plus calcium hydroxide equals 2 sodium hydroxide plus calcium carbonate. This green liquor is sent to the causticizing cycle. It is mixed with slaked lime, calcium hydroxide, so that sodium carbonate plus calcium hydroxide equals 2 sodium hydroxide plus calcium carbonate. In effect, almost all sodium and calcium are recovered. Sodium returns as sodium hydroxide white liquor, and calcium returns to calcium oxide for reuse. Condensates are reused to the extent possible. The brown stock washers operate countercurrently. Fresh wash enters the final washers, and weak liquor is extracted from earlier stages. Condensate from the evaporators, virtually pure water, is recycled into process water. As a result of such loops, modern pulp mills have their freshwater demand compared to older systems. AQ is catalytic, shuttling between anthraquinone and anthrohydroquinone, AHQ. Initially, AQ is reduced by carbohydrate N groups to AHQ. AHQ then reduces lignin structures and regenerates AQ. This redox cycle protects hemicellulose ends, preventing peeling, and cleaves VO4 lignin bonds, raising pulp yield. In practice, adding approximately 0.1% AQ by weight raises pulp yield approximately 3 to 4% at the same delignification. Because AQ is largely unchanged by the cook, most of it returns in the black liquor. Only small fractions are lost, e.g. by forming anthanol side products, and must be made up. In short, AQ operates in a near-closed loop. It catalytically promotes delignification while requiring only minor replenishment. The higher yield and lower carbohydrate loss mean less biomass and caustic per ton of pulp. SISAL line fiber also is used as feedstock for high-quality specialty pulp used in specialty paper products, such as tea bags, plug wrap, and surgical gauze. For the tea bags, it's already have an application for making Folium agave sisalani tea bag, the products with high tear resistance, high alpha cellulose content, high porosity, high bulk, high absorbency, and high folding endurance. Application: packaging xylins are hydrophilic in character and show good properties towards oils and fats, but do not act as good barriers, as films, for water. They also possess other properties such as low oxygen permeability, aroma permeability, and high light transmittance, which make it suitable for packaging applications. Lignin, extracted from black liquor, can be used as binder, emulsifier, dispersant, and sequestrant. Hemicellulose, getting from the step of cooking, utilized in food additives and thickeners.